Hi everyone, this is the start of KC3 characteristics of polynomial functions for integrated 3 math. Okay, so the first section, section 3.1, is covering power functions. Okay, and I'm going to go over exactly what a power function is. But before we start that, I want you to go ahead and try these 3 warm-up problems and evaluate each expression when x is equal to 2 and x is equal to -3. Okay, so go ahead and pause this video before I move on and try to complete that. Okay? Alright, so number 1, you are going to plug in 2 and -3 individually. So you're going to do 2 problems for number 1, 2 for number 2, and 2 for number 3. Okay, so for the first one, I'm going to go ahead and plug in 2. So 2 to the 4th power will give me 16. And that's it. That's my answer, 16. Now, -3, when I plug that in, I want to make sure that every time you have a negative number, you go ahead and put that in parentheses. Because if you don't, you're going to get a different answer. Okay, so for -3 in parentheses to the 4th power, I get 81. However, if I don't plug in the parentheses for that negative number, it would be -81, and that would be wrong. Okay, so make sure that you are using parentheses every time you have a negative number or you're given a negative number. Okay, so for number 2, for example, I have -x squared minus 1. Now, I'm going to plug in 2, but 2, my original 2 here, is not negative. So I don't need parentheses here. So I have -2 squared minus 1. -2 squared is -4 minus 1 will give me -5. And I'm going to do that again for the -3. So I have the negative from the original function here, but my number is negative, so I do need parentheses there. Minus 1. This will give me a -9 minus 1, which is -10. Now, if you notice, number 2 and number 3 are very similar. The only difference here are these parentheses. That's going to change my answer because of the parentheses. Okay, so if I plug in 2, I have -2 this time, because I have parentheses now, minus 1. Now, a -2 times a -2 will give you a positive 4. And 4 minus 1 is 3. Okay, so notice that because the number 2 didn't have parentheses, and number 3 did, my answers changed. I went from a -5 to a positive 3. Same thing with my -3. I have a negative, but again, I have an extra parentheses because it's a negative number, minus 1, which will give me a positive 3 here. Because I have 2 negatives, so 3 squared is 9, minus 1 is 8. Okay, now this was just a warm-up. Now, a power function. A power function is a function of the form f of x is equal to ax to the n power, where n is an exponent and positive. We are not dealing with with negative exponents yet. Okay? Now, I want you to go ahead. We have 6 different graphs here. Okay, so pause this for a little bit, draw these 6 graphs, and then we are going to draw what they look like. All right, so for my first graph, I have f of x is equal to x. Now, if they do not have an exponent here, it is always a 1. Okay, so x to the 1st power, anytime you have a variable to the 1st power, it's going to be just a linear function. Okay, you guys should have covered this freshman and sophomore year. Okay, the second graph, I have x squared. So the general function for x squared is, remember, that is a quadratic. We covered that in the first unit. It looks like a U. Going up. Now, f of x is equal to x to the 3rd. We've also done this. We did it in the last unit, and that was a cubic. So it's going to go through the origin, and it looks something like this. Now, x to the 4th, 5th, and 6th, we haven't covered. However, they are very similar to what we've already done. Now, x to the fourth will look like a u as well. X to the fifth, you guessed it, is going to look like a cubic, and x to the sixth is going to look like a u again. Now, if you notice, the only difference between these graphs from x squared to x to the fourth to x to the sixth is that my u, my parabola, is getting wider. Okay, it gets flatter here towards the bottom. Okay, every time you increase that exponent. And the same thing for my cubic function, x to the third and x to the fifth, it gets flatter here towards the origin. And that is the only difference. Okay, now these are called parent functions. They go through the origins, and these are the general graphs of these functions. Okay, now you could change these with transformations, which we will talk about a little later. Now, look at patterns here. When we have an even exponent, we know it's going to look like a u, right? This is a parabola. My arrows, if you look at, x squared, x to the fourth, and x to the sixth, go in the same direction. Okay, so this is what you're looking for even in even functions. If the arrows are going in the same direction, either they're both going up or they're both going down, and it looks somewhat like a u. Now, if you have an odd exponent, that means that the arrows go in opposite direction. Okay, so my arrows go in opposite directions. So one of them is going to be going up, one of them is going to be going down, or vice versa. Okay, now functions are either even, odd, or neither. That is how functions are classified. Okay, so you can tell whether a function is even or odd graphically and algebraically, and I'm going to show you both of those ways. So the first one is graphically. Okay, so if I have a graph here, now I want to show the even function. Okay, so for my graph, now we already know that an even exponent will look like this. Okay, so this is, again, the function f of x is equal to x squared. So notice the symmetry. So that is what you're looking for in an even function. You're looking for it to be symmetrical, or the symmetry over the y-axis. Okay, the y-axis is like a mirror. If I fold the y-axis, my graphs, my lines would be right on top of each other. If that happens to any graph, it doesn't have to be a U-shaped graph. It can be any random graph. But if you fold it over the y-axis and it's the exact same thing, when you, like, it's directly on top, that is an even function. Okay? Now the opposite of that would be an odd function. Okay, so if it is an odd function, right, for example, if I give you a cubic function, okay, x to the third has an odd exponent, it is an odd function. Here, you are looking at the origin. Okay, and if you remember, the origin is at 0, 0, right in the middle. If this is rotated 180 degrees, you should get the same graph. Okay, now I know it's a little hard to see, but if I rotate this literally turn this whole thing where y, the top of my graph, my y is now at the bottom, I will get the same graph. Okay, so I did show this visually in class. It's harder right now on a video, but I grabbed a piece of paper and I drew this exact same graph, and I literally just rotated it 180 degrees, and you still get the same graph. Okay, now this is graphically. So if you're able to do that and you get the same graph, it is odd. Now, it looks like you have a U, but it's not folded over. Like if you fold it over and it's not directly on top, then we would say it's neither, and the same thing for an odd function. Okay, now, you can also see whether a function is even or odd by figuring out algebraically. Okay, so it is an even function when you have f of negative x equal to f of x. Now, what exactly does that mean? Okay, now to do this, I'm going to go ahead and give you an example. It's so much easier when you have an example. So, for example, if I tell you that f of x is equal to x squared plus 4, everywhere I see x, I am going to substitute for negative x. Okay, and then we'll see what happens after we simplify. Okay, so I'm going to have f of negative x equal to negative x squared plus 4. Again, don't forget to write your parentheses here every time you have a negative term. Okay, so we already know that when you square a negative number, again, a negative times a negative will give you a positive. So this will simplify to just a positive x squared plus the 4, because nothing happened with that 4. So if you notice, the original function f of x is equal to x squared plus 4. When I plugged in a negative x and I simplified, I also got x squared plus 4. So these are the same function, even though for one of them was f of negative x. When that happens, we say that f of x, or f of negative x, is equal to f of x, which means that it is an even function. Okay, so if the functions are both the same, if f of negative x is the same thing as the original f of x, then it's even. Now the other way around, I can have an odd function when I have f of negative x equal to negative f of x. Okay, so this one's a little different. So again, I'm going to give you an example. Let's say that I have f of x equal to x to the third minus 2x. I'm going to do the same thing that I did before. I'm going to plug in negative x wherever I see x, and that's in 3 different spots here. So I have f of negative x equal to negative x to the third power minus 2 times negative x. Now I'm simplifying, right? So the first part stays the same. But now think about it this way. I have a negative x to the third power. I need to figure out if my answer is going to be positive or it's going to be negative. Okay, so every time you have a or an odd exponent, your answer will be negative. Every time. Same thing happens here, right? In the previous example, I had squared. This is an even exponent. So when you have an even exponent, you have a positive answer. Okay, so let's go ahead and continue this. So if I have negative 3 or negative x times negative x times negative x, I get a negative x to the third power. And then here, I have a negative 2 and a negative x will turn into a positive 2x. Okay, so now I want you to look at the original function and the function you simplified. So if I look at these, I went from x to the third minus 2x to negative x to the third plus 2x. Now, these two functions are opposite of each other, right? It went from a positive x to the third to a negative x to the third. From a negative 2x to a positive 2x. They are the complete opposite. So, opposite functions here. When that happens, okay, Now I have f of negative x gave me the opposite of f of x, which means it is an odd function. Okay, now if you have a combination of the two, okay, like if you have some terms that are the same and some that are opposite, then we say it's neither. Okay, now we did do some practice with this, so make sure that you ask me for the practice, and if you have any other questions, please let me know. But that's it for